And we're going to start by reviewing limits from a graph. So I just want to remind you that yes, your final is going to be largely based on the second portion of the class, so the stuff that we've done in class since the midterm, but that all of the things before the midterm are still included. So today we're really going to start trying to remember the things before the midterm. You will have limits, you will have limits and derivatives from a graph, that type of thing. So we're going to start by doing question 1 here, where we're evaluating limits from a graph. So I'm going to do a few of them by myself, just talking about them, and then I'm going to maybe ask you guys to evaluate a few as well, just to make sure that you're remembering how to do this. So the limit as x approaches -2 of f of x. What this is telling me to do is go find -2. So that's -2 right there. And because it's not a one-sided limit, I don't have anything happening on the left side or the right side. I don't say from the left, I don't say from the right, I just say at -2. That means I have to look at both sides. So I'm looking at both sides and I'm following the graph back until I get to 2. And what is my y value when I get there?
0.
You got it, 0. So the y value when I get there is 0, which means that this limit is 0. Is f of -2 also 0?
No.
What is f of -2 here?
Isn't it 4?
Isn't it -3?
Yeah, wait, 1, 2. -3.
-3. So it actually does exist. It's not does not exist, because remember that f of is saying where is the closed dot. And in this case, that closed dot is at -1, -2, -3. So f of -2 itself is -3. If there had been no closed dot there, then it would have been does not exist, right? Because we have an open dot at the place where the limit happens. What kind of discontinuity is this? Is it?
Removable.
It's a removable discontinuity. So be careful, because even though I do have that like gap between where it's defined and the limit, jump is when I have graph and I have graph and the graph starts and stops at different places. Removable is when the graph is going to the same place on both sides, but f itself is just in another place. Good. Okay, so the limit as x approaches 2.
1.
You got it. That one's going to be 1, because again, it's saying, look at the left side and the right side of 2 and go back to the graph. And then here, that gives me a 1. Is this also a discontinuity?
Yeah. Sorry.
What kind of discontinuity is this one?
Removable?
It's also removable. So even though there's no definition somewhere else, there's no like closed dot anywhere, I still have the graph going to the same place on both sides. It's just then not defined there. So we're going to answer those questions in K when we get there. Okay. 4 from the left. 1, 2, 3. This is 4. 1, 2, 3, 4. That's 4. Tell me privately in the chat. A couple of you already told me. Privately in the chat, what's happening on the left side? Good job, guys. So here we have a -1. Exactly. So wait, what about the? We have -1. But what about if I were to ask you the limit as x approaches 4 from the right of this function? That would give me a +1. Good job, guys. So there I have my +1, which tells me what about the limit as x approaches 4 itself? You got it. Good job. Does not exist. And then as Sandra said, this is actually a jump discontinuity. Everything okay, Ellie? Oh, no. This is actually
Made a
a,
mistake.
okay. This is actually a jump discontinuity because we have our graph going to different places on both sides. Okay, the limit as x goes to negative infinity. What's happening there? Good job, guys. It's on its way up to positive infinity. So if I follow the graph this way, if I'm like x is on its way to negative infinity, then my y values are getting bigger and bigger and bigger, and this becomes infinite. But on the positive infinity side, what's happening to my y values? Yeah, you guys got this. All right, so this h right here is a little bit of a tricky question, because it's not f of x, it's 1 over f of x. So this is saying the limit as x approaches -4 of 1 over f of x. So this is -1, -2, -3, -4. What is the limit as x approaches -4? Of just f of x, not 1 over f of x. Yeah, good job, 0. Which means that when I plug in here, I get 1 over 0. And what does a constant over 0 mean? So it could be infinity. It could also be negative infinity. It could also be does not exist. But in this case, I can get rid of the d and e because it's one-sided, right? That left there tells me I can get rid of the d and e. So how do I figure out if it's positive or negative infinity? I go to my graph. This is -4 from the left, just to make that really clear. So that means I'm on the left side of -4. Are the values positive or negative there?
Negative.
Left side of -4.
Positive.
Oh, sorry.
Yes. So here my y values are positive. So that means that the answer here is positive infinity because the whole thing is positive. So the answer is just positive infinity. All right, last one, -1 from the left.
Isn't it from the right?
Yes, it is. -1 from the right. You got it. So if I'm on the left side, it's going up to positive infinity, but since I'm on the right side here, I see those values are getting smaller and smaller forever. So this is just negative infinity. All right, f prime of -3. So this is saying, what is the derivative at -3? Well, this is -3 right here. I have my function. If I were to draw my tangent line is going to look like that. It's just going to be a horizontal line. What is the slope of a horizontal line? Yeah, you got it. So the value is -1.5, but this is f prime. It's not f. So the slope of a horizontal line is just 0. And this is because slope is 0 at -3. His power went out. He'll be so happy to know you guys miss him. No, his power went out. I think that it's out in a certain region. I got like 3 messages from people saying their power went out. I wish that I could record the chat and then he would see it when he's watching the video. You'll personally bring his power back on. He'll be so happy to know. Okay, what other questions could I ask about the derivative? So I'm going to separate this into 2 questions. What other way could I ask you for the derivative? So I could say f prime of -3. Is there another way that I could ask that question? And that I have in the past asked that question?
You could ask like where it's differentiable.
So yeah, I could ask where it's differentiable, but what I mean is like specifically at this point. We've said that you could also ask this in terms of the limit definition of the derivative. So I could do -3 plus h minus f of -3 over h. And this would just be another way of asking that exact same question. Right? So if this shows up, remember that this is another way of asking for the derivative. So yes, Maureen. As annoying as that is, this could show up. What was specifically is not on the final is we're not going to ask you to calculate a derivative using that definition. So like this question right here, question 5 will definitely not be on the final. But to my knowledge, that type of question could still be there. So like definitely you're not going to have to do this. But recognizing that it is the derivative, you might still have to do. You won't have to specifically state it or remember it off the top of your head, but you will potentially have to recognize it. I'm sorry, Sandra. Okay, so next, we kind of talked about this along the way. Starting from left to right, what's my first discontinuity?
-1.
-1, and we already said that that one is removable. So x equals -1 is removable.
Oh, I think I didn't say -2, but there's -2, I think, and -1, no?
Oh, I'm sorry. Yeah, I was talking about -2 anyway. -2, yes, thank you. We said -2 is removable, and then we also have -1. I don't know how you can forget that dot. Like, it keeps bothering me so much. I keep thinking that it's like a marker that I accidentally put, and I keep wanting to erase it. Like, how can you forget that dot? It's so annoying. I wish my brain could erase it. I feel like really neurotic about it, actually. Okay, so x equals -2 is removable. X equals -1. We also have, what kind do we have at -1? You got it. That one's infinite. And then Cam said that the next one that we have is 2. So x equals 2. What kind do we have at 2? We also already said this one's removable. And then next was x equals 4. What kind is x equals 4? That one is a jump. Am I breaking up for you guys a lot? Am I lagging or anything? Okay, give me 2 seconds. It's possible this is gonna. Okay, I'm gonna switch internets, and it's possible this is gonna kick me out of the meeting. So I'll come back. Give me 2 seconds. If the meeting closes, just sorry, hold tight. Okay, hang on. This disappeared in the meantime. Okay, so is it going to show up? Okay, so for what values of x is f continuous but not differentiable? So Sandra had mentioned one of these earlier. Remember, this is going to be, well, actually, 1. You got it. So x equals 1 is really the only place this happens, and that is a cusp. So we're going to put it, label it as cusp corner. What other type of place could this have happened that did not show up on the, or that didn't show up on this graph, or did it? You got it, Alex. Good job, Xavier. 3. At 3, we also have a place. And what's happening at 3? It's not a horizontal tangent. Horizontal is this way.
It's a vertical tangent line.
It's a vertical tangent line. You got it. Vertical tangent line. Okay, so those are the only two places that I could have a place that it's continuous but differentiable, but not differentiable. So that kind of covers it. Are there any questions about limits from a graph or understanding differentiability or continuity from a graph?
Actually, yeah, I have one.
Okay, what's up?
For H,
Yes.
what if it asked, I think that says on the left. What if it asked on the right? Because it's negative, but then it also becomes positive. Like it goes from positive to negative and then to -4.
Okay, so if I were to do -4 from the right, then I would be looking literally just at that place that's right to the right of -4. So like right there, do you see like where I just drew that colorful dot?
Mm-hmm.
Okay, are my y values there positive or negative?
They're negative.
They're negative. So what that means is I have 1/0, but I can kind of think of that as a -0.
Yeah.
So then this would be negative infinity.
Okay. And
Whereas
even
when
if
I was on the left
it's-
side of -4, those values were positive, so this was like 1/0 from the right.
Okay. So even if it's like on the right, technically going up to positive infinity.
We're looking at the y, the sign of the y values.
Okay.
Okay, if I were to ask this, the limit as x goes to -4 of -1 over f of x from the left, then this would be -1 over 0 from the left, and what would that give me?
Would be negative.
So it would actually be positive infinity here, because even though these values down here are negative, that -1 on top makes the negatives cancel out. Did that make sense?
Wait, wouldn't it be negative over positive?
Oh, I'm sorry. I meant to do, wait, from the left. Oh yeah, I'm sorry. It would be negative over positive. You're right. My bad. I was doing from the right in my head. So
Okay.
that would be positive, and then that would still be negative infinity. You got it.
Yeah, okay.
Okay, good. Okay, so Xavier, you don't understand why 3 is not differentiable. So at 3, notice I have this like mini dotted line right there. And the reason is because my tangent line is a vertical tangent line. So I know that the slope of a horizontal line is 0. We say that the slope of a vertical line either doesn't exist or is infinite, because I know that slope is change in y over change in x. But if my tangent line is vertical, there is no change in x. So that change in x would be 0, and then I would have a constant on top. And so that stops me from being able to find the derivative there, because I have that division by 0 in the slope. Does that make sense? Okay, so just one last thing. One other thing that you might potentially be asked to do from a graph is to evaluate the derivative at a straight line. So if I were like, hey, look, find f prime of 1.5, how would I do that?
Would you do like the second y minus first y divided by x2 minus x1?
You got it, exactly.
Okay.
So I would choose my 2 points. And like here I have 2 clear points. My points here are 2, 3, and 1, 1. So I would do 3 minus 1, change in y, over 2 minus 1, which actually gives me a 2. So then my answer here would be 2, and we found the slope that way. Do you guys remember doing that? Guys, look who's here.
Yeah, my power went out. I don't know. Yeah.
Yeah, I think you're not the only one. I was saying that a couple other people messaged saying their power went out. They missed you. They talked about you.
Thank you for that.
Our Lord and Savior. Wow.
Oh,
Okay.
oh boy.
Wow.
All praise.
Prodigal son returns.
Okay, all right. Okay, so any questions about derivatives of anything from a graph? Oh, hi, Cam, as well. All right, then. We're going to evaluate some limits. So I want to remind you that, again, I know I've said this like 8 times this class already, that you guys are going to give him a big head. So the focus of this exam is definitely more on stuff after the midterm. So like this exam has 6 limits on it. Hands down, your exam is not going to have 6 limits. But we're still going to do them all because you never know what kind is going to show up. So we're going to start with A here and just see if we can remember all of the techniques that we've learned. So A was the limit as x approaches -4 of 2x squared plus 5x minus 12 over x squared plus 7x plus 12. And what is the first thing that we should always do when we're evaluating a limit?
Check if it's division by 0 or 0 over 0.
You got it. We plug in and see what happens. So what do I get here?
I just got tingles there. From him jumping in there.
-12. Don't you get -1 if you plug in 0?
Where do I get -1?
If you plug in,
We're not plugging 0, we're plugging -4.
Yeah, we're plugging in
my
-4.
bad.
It's probably
Oh, I see what you mean.
0 over 0.
My bad, David.
No problem.
So we're plugging in the -4, and we do indeed get a 0 over 0 when we plug in. So I want you guys to tell me privately in the chat, what does that mean about the factor that I know I have? What factor do I 100% know about? I want a whole factor, not just a number. All right, good job, guys. So that means I'm trying to get an x plus 4 out. So that means we're going to do the limit as x approaches -4. And I know I'm going to have an x plus 4 on top. And I know I'm going to have an x plus 4 on bottom. So what is my other factor on top?
2x minus 3.
You got it. So I know that to multiply x, I have to multiply x by 2x to get 2x squared. And I'm asking myself, what do I multiply 4 by to get -12? And the answer is 3. And then on the bottom, it's pretty straightforward. It just becomes an x. Good job, guys. X and 3, x plus 3. So then I cancel. Goodbye. Goodbye. And what do I do next?
You're going to plug -4.
I plug in -4 again. You got it. So I'm like -8 minus 3 over -4 plus 1, which gives me a positive 11.
Why plus 1 at the bottom?
Huh?
Why did you do -1 plus?
Because I just
3.
wrote a 1 instead of a 3.
Yeah.
I think because I was already getting the -1 in my head. So that gives us -11 over -1, which is just positive 11. So this is one of the techniques we learned for taking limits. We learned that sometimes we just have to factor and cancel. We also learned a few other techniques, so let's go ahead and look at B now. Again, we always want to start off by plugging in. So when I plug in here, what do I get? I want you guys to plug in, let me know.
0, 0.
0. So I get 2 minus 2 on the bottom. That's clearly a 0 on the bottom. And then 2 plus 2 is 4 over 2. So this is like 4 over 2 minus 2 over 1, which does give me a 0 over 0. So the method that we use here is called clearing denominators. We remember that we want to multiply the numerator and the denominator by those original denominators. So in other words, I'm multiplying the top by x times x minus 1, and I'm multiplying the bottom by x times x minus 1. And what's the factor that I know that I'm ultimately going to try to cancel out?
X minus 2.
X minus 2, you got it. Okay, so I'm going to go off to the side to do the like hard work of distribution here. So I'm going to have x plus 2 over x minus x over x minus 1. And I'm taking all of that and I'm multiplying it by x and x minus 1 that I'm then distributing to the inside here. So what is my x plus 2 ultimately going to be multiplied by?
X minus 1.
X minus 1 minus what is my x ultimately going to be multiplied by?
X.
Good job. So now I need to expand this and combine like terms. And I'm going to do this all on the side because it's going to make my life a little bit easier later to have this as simplified as possible. I'm going to have x squared plus 2x minus x minus 2 minus x squared. And I get x squared minus x squared. And look at that. I actually just have a nice simple x minus 2 left over. Yay! Good job, Gabriel. So then I can go stick this back into my limit exactly as it is. My numerator became x minus 2. My denominator is 2 minus x times x minus 1. Okay, privately in the chat, tell me how am I going to get the x minus 2 in the denominator? We're so good at this. Okay, so two answers. I got two answers from you guys, and they're both good answers. I can either factor out a -1, and that's my preference, is that I'm just going to factor out a -1. So I'll have -1 times x minus 2. I've factored out my -1 times x minus 1 times with an x minus 2 on top. The other thing that you guys said is that I could multiply by -1, and that's also an option. But if I multiply by -1, I'm doing it on the top and the bottom. Right, so that would be like multiplying by -1 over -1, and that's also an option. So now I'm going to cancel out my x minus 2's. Tell me in the chat what the final answer is. Luke, I think you messed up somewhere. So just because I'm still getting a couple weird answers, I'm gonna actually rewrite the limit with things canceled out. So x approaches 2, I don't have anything left on top, which means that I have a 1 there. And then in the denominator, I have -1 times x minus 1. I canceled out those x minus 2's. So now when I plug in 2, I have a 1 on top, I have a -1 down here, I have 2, and then I have 2 minus 1, which ultimately results in a -1/2. So I'm gonna be honest, a couple answers I really have no clue where they came from. So I don't know how to like tell you what you did wrong, but does this make sense? And are there any questions for those of you that weren't quite there? So be careful because the x times x minus 1, remember, is only left in the denominator. The numerator became that when I multiplied by it. All right, any other questions about this problem?
Could you just do again the like multiplication?
The line that I have in green right here?
Yeah.
Okay, I'm gonna erase it and just start over then. We'll just do it one more time from scratch. Okay, so basically we're saying that x times x minus 1 is getting distributed to both of the things inside there. So I'm gonna have x plus 2 over x times x minus 1 minus x over x minus 1 times x minus 1. What ultimately happens in the first term is that those x's cancel out. And what happens in the second is that those x minus 1's cancel out. So then I have x plus 2 times x minus 1 minus x times x.
Okay. I see.
Right? That makes sense?
Yeah.
Which gives me x minus 2. Goodbye, goodbye. Okay, are there any other questions about this limit or about canceling denominators? Then let's do C. As usual, we plug in first. What do I get when I plug in?
6 over 0? Oh no, 0 over 0.
I actually get 0 over 0 again. You got it. No. I get 0 over 0, which means that I want to factor. What is the factor that I know I have?
X plus 3.
X plus 3. You got it. So then we're going to factor the denominator. Oops, I will have the limit as x goes to -3 from the right of x plus 3 over x plus 3. What's my other factor in the denominator?
X plus 3.
You got it. There's another x plus 3. Good job, guys. Another x plus 3 down there. I cancel those things out. What does my numerator look like now?
1 over x plus 3.
You got it. So now I have 1 over x plus 3. Good job. When I plug in again, what do I get?
1 over 0.
0.
Okay, I want you guys to tell me now in the chat. I know we already mentioned this earlier. Who remembers? What does 1 over 0 mean? Privately in the chat. I'm confused as to what that means, Matt. So typically 0 over 0 means a removable discontinuity. So in A, I could easily conclude that that function has a removable discontinuity at x equals -4. But this 0 over 0 turned into a constant over 0. And we remembered earlier, so good job guys that said this, that a constant over 0 means either negative infinity or does not exist. So it could be any of those three things, but I can actually get rid of the does not exist in this case. Why?
Because it's a one-sided.
Good job, guys. Yes, because it's one-sided. So because one-sided, I can get rid of it. What technique do I use then to figure out if it's negative or positive infinity?
You replace by minus 2.9.
You got it, exactly. So I'm looking at something on the right side of -3. I take a number that's close and I look for a sign. So like back up in the graph, we were looking at the y values that were close and we were like, hey, look, these y values are positive, these ones are negative. Now we're doing the same thing, except we don't have a graph. So instead we're gonna say, what's a value that's on the right side of -3? And the answer is -2.9. So I plug that in. 1 over -2.9 plus 3. Is that positive or negative?
Positive.
Positive. So which one do I take?
Positive infinity.
You got it. You got it. It was positive, so I'm going to take positive infinity. Voila, that's my final answer. So this one, even though it started off as 0 over 0, it was not a removable discontinuity. It ended up actually being an infinite discontinuity, even though we started off with that 0 over 0. And that's something you always want to pay attention to. Just because you've done the factor and cancel doesn't mean there's not also another method that will follow. Far so good? Questions? Shall we do D?
Yes.
Yes. Let us do D. Oops. So the big stuff, yes, you got it. This one's take the big stuff. Good job. The big stuff method only works when we have limits at positive or negative infinity. So in the previous question, that C, our limit was x approaches -3. So I definitely cannot take the big stuff. The big stuff will only work when I have x approaching positive or negative infinity, which I do in this case, which means I can take the big stuff. And if I take the big stuff, well, what's the big stuff on top?
6x squared over 9x squared.
You got it. So I'm having limit as x goes to infinity. We're taking the big stuff. I'm going to do that in 2 steps. I have 2x and I have the 3x. This 3x is being squared, which means the 3 is also being squared. So I have 2x, 3x over 3x squared. You got it. So that's going to be 9x squared. Good job. So limit as x goes to infinity, this becomes 6x squared over 9x squared. And then can I cancel out those x squareds?
Yep, and then you get 2 over 3, sorry.
You got it. So then I have that equals to 6 over 9, which is 2 over 3. Does this thing have a horizontal asymptote?
Yeah. At y is equal to 2 over 3.
At y is equal to 2 over 3. So this is one of the things we calculated, and we were using to calculate horizontal asymptotes. Remember when we were doing curve sketching, we had to like bring this back up and do it again. So, but we had to do it all on our own, not as a limit we were given. We had to recognize, oh, hey, that's how I calculate horizontal asymptotes. Guys, it is like a freezer in my house. I feel like I'm sitting in an ice box. I hope that your heaters are on. Okay, E, y'all ready? Whoa. It was that important to have him in
All right,
class?
my bad. Hell yeah, we're ready.
Thank you, Cam. Xavier took my power and transferred it to David. Just
Yeah.
thank you. That was super kind of you. Limit as x approaches -1 of x plus root 2x plus 3 over 2x squared minus 2. Come on, guys. A worthy sacrifice. What? I'm freezing. Okay, so when we plug in here, we get 2 minus 2 on the bottom and -1 plus the square root of 1 on top. We do get 0 over 0. What I want you guys to do privately in the chat right now, tell me how to do this problem. I'm going to multiply the numerator and the denominator both by what? Tell me what I'm multiplying by on the top and the bottom. Yes, except what is it? So give me the actual thing. There you go, Sandra. Good job. So a lot of you are getting there. So some of you are changing the wrong sign. Okay, so most of you are there. Some of you are saying that I should just multiply by the square root, but that is wrong. Remember, I'm multiplying by the conjugate, and the conjugate is when I change the sign in between those things. So in this case, what that means is I'm doing x minus that square root and x minus that square root. So it's not just the square root, and I'm not just squaring both things magically. I'm multiplying by x minus the square root. Notice I don't change the sign inside the square root. It doesn't become 2x minus 3. I'm only changing the sign between the two parts. So I'm going to do this work off on the side as well. I have x plus the square root of 2x plus 3 times x minus the square root of 2x plus 3. And because this is a difference of squares here, I end up with x squared minus the square root of 2x plus 3 squared. Is that correct?
Shouldn't it be -3?
Should be -3. Be careful, that minus sign is going to get distributed to both of the things inside here. This is not a +3, and I'm going to actually leave that plus there. It should be a -3. What's the factor I know I have that I'm trying to get rid of?
X plus 1.
X plus 1, you got it. So with that in mind, what that means is if I did things right, I should have a factor of x plus 1 here. Do I?
Yeah.
What's
X plus
the other
1 times x minus 3.
Times x minus 3.
X minus 3.
So I'm just going to expand this really quickly to make sure that that factor of x minus 1 is 1 actually shows up. So in other words, this gives me x squared plus x minus 3x minus 3, which does indeed equal to x squared minus 2x minus 3. So yes, that x plus 1 showed up. If I had accidentally put plus 3 instead of minus 3, would the x plus 1 have shown up?
No.
No. Same up here. If I had messed up my minus signs, the x minus 2 wouldn't have shown up. And that would be a clear sign that I distributed incorrectly, that I messed something up somewhere, right? So always double check yourself. If it doesn't show up, say, what did I do wrong? I know this is supposed to be there. Why isn't it there? So that means that here I get the limit as x approaches -1 of x plus 1 times x minus 3 over something times x minus root 2x plus 3. Again, privately in the chat, tell me how you're going to factor the bottom. So I can't take out minus 2x because the second 2 doesn't have an x. That's, yes, so like, yes, Ellie, that's what's there, but I want to know how are you going to factor it to find the x plus 1? I'm confused because it looks like you just wrote what I already have. Yes, good job, Michael. Good job, Lucas. Good job, Gabriel. Not quite, Ellie. Yes, Alex. But it could be that you just have like an extra 2 in there by accident. Okay, so there are 2 ways that I could approach this. The first thing that the way that I like to do is remembering a difference of squares. So a difference of squares is really like the main concept of this problem. It's what I was using to do the conjugate. It tells me that a squared minus b squared is equal to a minus b times a plus b. So that's one way that I could do this. I could start off by saying 2x squared minus 2 has a greatest common factor of 2 that I could factor out, and then have 2 times x minus 1 times x plus 1. Or I could say 2x squared minus 2. I know that x plus 1 is a factor. If x plus 1 is a factor, what does the other factor have to be? What do I multiply x by to get 2x squared? 2x. What do I multiply 1 by to get -2? -2. And based on the different answers that I'm seeing in the chat, I'm guessing some of you did the first way and some of you did the second way. And either way is totally valid. So I'm going to stick this up here like this. And then cancel out my x plus 1s. Are there any questions about the difference of squares and the factoring that we just did there? Okay then, I'm going to rewrite my limit. X approaches -1 of x minus 3, 2 times x minus 1. Many of you messed this up on the midterm. Don't forget to write your conjugate in the denominator or the numerator or wherever else it's supposed to be. So I'm going to have x minus root 2x plus 3. That has to be down there. Now I'm going to plug in again to get -1 minus 3, 2 minus 1 minus 1, minus 1 minus the square root of 1. And I end up with another -1/2. Okay, are there any questions about this finding the conjugate and the rationalizing that we did here?
I'm confused on how you did the multiplication in green.
Oh crap, hang on, the multiplication where?
With the square roots, like in green.
So actually I was using the fact that because I multiplied by the conjugate, what I have is a difference of squares, right? So like, if you go back and look at the difference of squares down here, this is saying a minus b times a plus b is equal to a squared minus b squared. And there are no middle terms, right?
Oh no, I mean like the
I know. But
Oh.
like we actually used this. So just like, are you still with me in terms of that?
yeah, that I
Okay.
get.
So then if I go back up and I look at what we did up here, what I have is a plus b times a minus b. I've created a difference of squares up here,
Oh.
right? So that means I only have to do a squared minus b squared.
Oh, okay. And then the square root just kind of.
And exactly, the square of a square root just makes it go away.
Oh, okay.
So like we're actually, like I was saying, like we're actually really heavily using the difference of squares in this problem.
Okay.
Okay, any other questions? All right, we have one last limit. X squared minus 6x plus 5. Am I going from the left or the right? The left. Okay, as usual, we start off by plugging in. When I plug in here, I get 0 over 0. How do I deal with that absolute value? Do I just pretend it's not there and move forward as normal?
You
Plug
replace
in a number that's left of 5 into it, and if it's negative, you put a -1 in front of it.
You got it, exactly. So I'm trying to figure out what the absolute value does. So here I have 5 from the left. What's a good number on the left side of 5?
4,
But really close to 5.
4.9.
There we go, 4.9. Good job, Canada there. So we're going to do 4.9. So then I have 4.9 minus 5. Is that positive or negative?
Negative.
That's less than 0. So the absolute value of x minus 5, we're going to multiply it by -1. You got it. Good job. So here we're going to have the limit as x approaches 5 from the left, x times -1 times x minus 5. What's the factor I know I have here?
X minus 5.
Good. How can I find it on the top?
Factor it out.
You got it. What's my other factor?
X plus 5. X plus 1. Sorry.
So exactly. So I'm like, what do I multiply -5 by to get +5? That is -1. So it's x minus 1. And now I can cancel out those x minus 5s. Privately in the chat, what's the final answer? So it's x minus 1, the other factor on top. Tim. Good job, guys. -4/5. What kind of discontinuity is 5? If you had to guess. It's a trick question, really. Well, I didn't get infinity here, so it's definitely not infinite.
Just a removable.
I'm gonna wait for a few people to answer before I say yes or no.
Aren't you like technically not able to know because don't you need the other side as well?
That's a really good point, Alex. Yes, but also because we did this work, we kind of know what the other side's going to look like. So that is a really, really key thing, though. I need the other side to answer that question. Will my other side also be -4/5? What do you think my other side will be?
No, it's going to be
Yeah,
positive 4/5.
It's going to be +4/5. So that means why I was saying this is a trick question, because it starts with that 0 over 0, which makes us think removable. But in this case, the left and right are different.
It's the
Exactly.
jump.
So this is actually a jump discontinuity.
Mhm.
Okay, so I just want to end today with, we just did a whole bunch of limits. There are a couple things that didn't show up that we learned, and those are largely involving factoring cubics. Do you guys remember some formulas for cubics that we learned?
Isn't it the thing where it's like
Is it
a
A
The what?
It's like-
times X plus
I like
A
kind of
times-
remember it, but not really. It's like A minus B, and then like A plus B, and like times A plus or minus B, something like
Yeah,
that.
you know, you're thinking the right thing. You're thinking the right thing. It's actually, we have a difference of cubes. And there are actually 3 methods that we saw. So we saw a difference of cubes. Does anyone remember the difference of cubes? So if I have a cubed minus b cubed, what does that equal?
Isn't it x plus a and then times x squared minus x plus a squared?
That is the sum of cubes.
Oh, then it's x minus a and then times x squared plus ax plus 9 squared.
You got it, which in this case looks like that in terms of a's and b's, since I wrote this in a's and b's, but exactly that. So the difference starts off with a minus, so the first signs are always the same. So then the sum of cubes, which is what Kiana said to begin with, the sum of cubes is a cubed plus b cubed, and because this is a plus, this means I start off with a plus. And then the sign changes here. Okay, so these are 2 formulas that you need to know. Kiana had memorized them in terms of x's. That's actually probably better because, I mean, usually we're going to have x's. In your notes, you probably have them in terms of x's as well. So Sandra, careful, it's always plus b squared at the end. Oh yeah, there you go. You messed it up. Yeah, so it's always plus b squared at the end. That's the only sign that doesn't change, no matter what. Also, something that's maybe useful is that neither of these 2 quadratic polynomials is ever factorable. You will never be able to factor more. Never factorable. Okay, so then the last, or rather the third method that we had, those were kind of our 2 methods, but we also saw factoring by grouping. So if we're factoring by grouping, hang on, we're just going to do an example because I think that's the best way. So I have x cubed plus 4x squared plus 2x plus 8. You guys remember how factoring by grouping works?
You take like the first 2, and then you factor those, and then take the second 2 and factor those. Like
You got
separate.
it. And so because it's the first 2 and the second 2, factoring by grouping is important or useful when I have a cubic with 4 terms. Useful when 4 terms. So I'm going to factor out my x squared here and my 2 here to get x squared times x plus 4 plus 2 times x plus 4. And then exactly, so be careful, because this, is this the right answer? Because it's almost the right answer.
No.
What's
It's
wrong?
parentheses x plus 4 times.
Exactly. So with this one, I'm just multiplying the 4 by x squared plus 2. I need to be multiplying the whole thing. Okay, are there any questions about limits or limit techniques that we learned? Where are the limits? There they are. There we go. So this really covered, aside from the fact that it was missing cubics, it covered most of the things that we learned in terms about limits, in terms of limits. Are there any questions about limits from a graph, anything like that? All right, then on Monday, we're gonna move on to continuity. We'll just keep doing the same exam. We'll move on to continuity. and derivatives. And hopefully we'll get through the continuity and derivatives questions and maybe even get started on some of the rest of the stuff. Okay, we are done for today.
All right,
So-
take care, man.
Thank you guys, and I'll see you on Monday. Have a good weekend.
Thanks very much. Have a good weekend.